Hello, my name is Amelia, and in this video, I'm going to be talking about the chip ecosystem. So think about every AI model you've ever heard of, every trading system on Wall Street, every cloud app on your phone. Behind all of them is one thing, chips. If there were no chips, there'd be no AI, no advanced manufacturing, no next-gen GPUs. So that's basically what this video is all about. Let's dive in with why chips matter. So, chips are literally the physical foundation of the digital economy. Every AI training run, every high frequency trading system, every robot and autonomous vehicle are just billions of transistors switching on and off in the right patterns. So, down here, you'll see 6 different examples of how each of these categories rely on chips. AI, finance, robotics, defense, cars, and the cloud. So this section compresses 70 plus years of technology into a brief timeline. Let's just dive into it just a little bit more. Here we start in 1947 with the transistor at Bell Labs replacing vacuum tubes. Then 1958 gives us the integrated circuit, where multiple components are placed onto one chip. 1965 is when Intel co-founder Gordon Moore observed that the transistor counts on chips kept doubling every year. That's when Moore's Law was conceived. 1971 brings the microprocessor, turning the CPU into a programmable engine for general computing. 1999 highlights the GPU, which originally existed for graphics, but eventually became the engine of deep learning. Throughout this video, you'll be hearing me refer to ASML, which used to be an acronym for a company called Advanced Semiconductor Materials Lithography. However, they dropped that full name and is only referred to as ASML to reflect the different partners that joined their venture over time. Anyway, around 2019, ASML creates the most advanced chip to date using their unique technology, which I'll go over in detail later. The 2020s is when GPUs, HBM, advanced packaging, and hyperscale data centers are more well known to the public. I mean, honestly, we wouldn't be where we are if it wasn't for each of the discoveries and inventions from these previous generations. Moving on to the ecosystems map, this section illustrates a very important idea, which is that no single company builds the AI chip alone. It really is an ecosystem of supply chains. So, right from the start, there are materials that are necessary to begin the process, which are silicon wafers, specialty gases, and chemicals. There are specialized equipment that are necessary to start shaping the materials into nanometer scaled usable products. Next, fabless chip designers like NVIDIA pass the chips down to foundries like TSMC and Samsung to manufacture the chips at scale. So as you go down this line, you'll see at the very end is where the AI users exist to utilize the end product for their specific fields. So next time when you hear that there's an HBM shortage, you should be able to identify where in the pipeline that constraint is. So next is ASML and EUV. EUV stands for Extreme Ultraviolet Lithography. It's a method of using light to print microscopic transistor patterns onto a silicon wafer. The analogy to help understand the relationship is if GPUs are the brains of AI, then EUV is the printing press that creates those brains. So as you scroll down, there's an animation that helps walk you through that process. Something to note is that ASML is effectively the single supplier of EUV systems at scale. Multiple independent sources describe ASML as holding a monopoly or near monopoly in EUV lithography, which it is essential for manufacturing the most advanced chips powering AI data centers. Without EUVs, The pipeline that I showed you previously slows down significantly. And whatever it is that you feel about AI, EUV technology is what's leading the AI boom, not the existence of data centers or even the demand for AI at the user level. On to the main players. Some of them you've heard of, and unless you're well versed in the AI pipeline, I'm sure many of the firms on this list you haven't heard of. The key takeaway is that different companies, they control different layers on the chain. There's the design aspect, manufacturing, memory, equipment, and tools. So the next time you analyze any AI related stock, ask yourself, is this company a bottleneck, a platform, or a commodity supplier? So moving on to the AI chip bottlenecks, we've got six main constraints: EUV machines that we mentioned earlier, high bandwidth memory. This is a big deal because there are so many reports that state that this supply specifically is sold out into sometime this year. The HBM market is growing well over 20% per year as AI workloads increase. There's advanced packaging, foundry capacity, which, by the way, a semiconductor foundry is sometimes called a fab. Energy here. This is the most contested area regarding AI in the public's eyes. Many people are deeply concerned about the environmental impacts of data centers because they require enormous amounts of power and cooling. So that is something worth mentioning. Which brings us to the geopolitics. Around the world, chips are truly considered strategic assets, not just products. Basically, the US leads in many parts of the pipeline, which is supported by the CHIPS Act incentives and a growing focus on tracking and controlling exports of advanced chips. Taiwan is the heart of the leading edge manufacturing. The Netherlands have ASML, which controls EUV lithography. Korea and Japan are critical in memory, materials, and equipment. China is both a huge market and a target of extensive export controls. Europe contributes equipment, automotive chips, and are creating sovereignty goals surrounding this topic. So next is the Intelligence Lab, where you can pick a company and read about its roles, key suppliers, key customers, its moats, and some of the key risks. So let's go back to NVIDIA. You'll see that it's a fabless AI chip designer deeply tied to TSMC and HBM suppliers with a moat built around CUDA, which, for those of you who don't know what it stands for, it's Compute Unified Device Architecture. Their risks include export controls and competition from AMD or custom ASICs. So here you can type in the answers of the question that's prompted here. Is this firm a platform, bottleneck, commodity supplier, or strategic choke point? This basically encourages you to start thinking more like an analyst instead of a consumer of tech news. And finally, here's the Knowledge Center. It gives you a glossary to review relevant words associated with this topic. And then here you can click on the quiz where you can test your knowledge. And that's basically it for this video. I hope that after watching this, you think of AI as more of a chain of components rather than this nebulous behemoth that you just can't wrap your mind around. Anyway, until next time, bye.